Hello, everyone. So today's topic is going to be creating web applications that scale. My name is Lokman Musliu, and the first slide is a bit of presentation of who am I. So the first two sentences are a bit cliche. So as a lot of people, I also began coding at a very young age. And I started my own company when I was the third year in college. At that time, I had this idea that I wanted to start my own company, as a lot of people do. And I basically started Lucky Media in 2015. Currently, I lead a team of 10 developers, one designer at our offices in Gostivar, which is in North Macedonia. We are working currently with small to medium and enterprise companies in USA, Europe. I mean, we have a very small user base of clients in Europe. Mostly we are focused in the States. In the States, we are mostly working with SaaS applications, with let's say websites that handle a lot of traffic. So we've been working on product development. We've been working on building bespoke websites and mobile applications. I have a few unpopular opinions here to share. Is everyone at the crowd in development or development? Yep, perfect. Okay, first unpopular opinion is that I still think PHP is cool. Second one is NPM is a terrible package manager and ecosystem. It's an unpopular opinion. If you use any in TypeScript, please go back to JavaScript with JS doc. Thank you. But unpopular opinion. And fourth, which is the one I like the most, is because X company is using, it does not mean it's good for you or your use case. I've heard this a lot. People say, but Facebook is using. And usually my answer is, but are you Facebook? No. Continue. Okay, next. So now I have a case study, a voting app for, and you see this black line is, usually this happens with companies that work abroad. We usually have to redact a lot of info because of signing non-disclosed agreements, so I can't share the client, but I can share the case study, which is what I'm about to do today. So, next. Okay, so what was the scope? So the scope is we have a voting application which has an admin area, and the votes are inputted in the system from the backend. Then there is an API service, a REST API, which pulls all the votes, let's say by city, by region, just like how we do here or in Macedonia whenever we have elections. You pull all the data related to all the country or all the cities through a REST API, and then we have a results page. So the results page is the public-facing part of the application. Usually the results page is just data that is expecting a peak, in our case, of 1 million users at a certain time. Here or in Macedonia, that would be like maybe 100,000, 200,000 at most in peak times when the votes are counted. So this kind of result pages, usually they have very small traffic, but there is a certain spike after a certain time, let's say after 7 p.m. or 8 p.m., and they will have to withstand all that traffic until a certain period, and then they go back to normal. So this page also needs to be dynamic, which means it needs to have dynamic filters by zone, states, zip codes, area codes, or whatever. So another point is that votes are updated every half hour. This is a very important piece of this results page, as usually people, they don't like to think a lot about data fetching and how often is being refreshed, or let's say how often is being updated. So what was the issue the previous years? So the previous years, the application was just your normal server-side application. They had a front end with Angular, I think, which was pulling all the data through an API, and then for each user, the API would be called, and then the results will be shown to the results page. I think it's a similar setup with what we have here also. So what you can do, because the data comes for each API call, you can have a DDoS attack, which in Macedonia happened 4 years ago. I'm not sure if that happened anytime here. So because the API is exposed from where the data is coming from, some bad actors, in this case, they can take that link and they can just bombard it with requests until the server gives up. So what does this mean? This means that there will be a very bad experience for users. They will see infinite loading times. You probably have witnessed that when you don't know if you're having a bad internet connection or the website is slow. But it will keep spinning indefinitely. As I mentioned, in peak times, those API calls from your client-side application, if it's like a couple hundred of users, 1,000, in peak times it means 1 million API calls in a matter of minutes. So let's say they're announcing the results will be live at 7 p.m., 7:02, 7:03, you have 1 million users at the result page all wanting to see the results. So what did they have? They had a very expensive server with the following features. So there is a load balancers, there was some Redis caching, some firewalls, CDNs, and the whole DevOps team, which I like to, which I call them. So they had the whole team working on this, and every time the results went up, everyone was 24 hours 7 because it will have downtimes and issues like that. Okay, so how do you solve this? Me, in 2019, I would have said just cache everything. Like, just cache everything, it should fix it. But of course, I didn't have that experience at that time. So, of course, we can solve that in this case. So what do we have? So in most scaling issues, you have two options. One is vertical scaling. That means for every, as we are getting more requests and more requests, we are increasing the size of the instance, the RAM, and everything. So if you're familiar to server provisioning tools, you just increase the RAM, increase the CPU, add more, add more, add more, until, I don't know, the bill goes a lot. Or then you have horizontal scaling, which is you just add more instances and instances, which I don't want to undermine this. This is very okay in certain scenarios. We are now just talking about our case study and how we solved it. So the question is, what happens at our results page if we do this? This will happen. So we pour in more money, we'll have more servers, which means more problems, most of the cases. In this case too. Also, image credits to This Ferin, what's his name? So as a front-end developer, or I don't consider myself a front-end developer, but let's say as front-end developers, we don't want to think about that. That's something that should be handled on the back end, and we want to build cool apps with animations. So what's the solution here? So usually the solution is static HTML with client-side React. How can we do this? You can do this with something which was mentioned a lot today called progressive enhancement frameworks or meta frameworks as Next.js. You have Nuxt.js for Vue. You have SolidKit for SolidJS. You have SvelteKit for Svelte. You have Astro.js, Gatsby. I think I covered most of them. So they're called progressive enhancement frameworks, and they basically exist for each front-end framework. So what you can do with them is, let's see an option. So this is the traditional approach in most of the applications, and on the result page, for every visit, so the user, he goes to the website, he has this HTML, CSS, JavaScript, your React application, Vue.js, whatever. Here you have an API call, the spinners are calling the server, and the server gets all the results at that time, and returns back to the API, returns back to the user gets the data. So this is a traditional approach, and as I mentioned, it's very okay for a lot of scenarios. You have real-time data or whatever, you need fresh data all the time, totally okay, but you need to do all the back-end stuff. Now let's focus if we have data that we need to periodically fetch and how we can improve our, let's say, decrease our costs while improving the user experience. So what does Next do is, if we have a bunch of users, they will get preloaded data. So that means they will see instant results, no spinners, because we are not making API calls in the front end. There is no use effect, there is no unmounted. So everything is returned as JSON. The JSON is then attached to the HTML, CSS, and JavaScript, and the users are seeing instant results. So what happens when we need to fetch that data? So all these requests go to Next.js, which in the background will make one API call, very important. This is going to be a serverless function, it's what they call it, and it's going to go to the server. So from the previous slide where we had like all the API calls, now we have just one. So this improves a lot the, let's say, the user experience, the backend load. We don't have to think about a lot of stuff. Every 30 minutes, our Next.js application in the background, it will call the API, it will clear the cache here, and it will display the user's new data almost instantly. So this is called incremental static regeneration. Another term for this presentation would have been how to use modern caching techniques, but being that caching is a very hard topic, I thought no one will show up, so I chose a bit of different name. So basically caching, what it does here, it's called stale while revalidated, which means the data here is stale, old, until it gets revalidated by Next.js. So the revalidation happens in the background, an instant refresh after certain minutes. So what did we solve? So the results page, using our current setup, we have Next.js, as I mentioned, to generate a static HTML with pre-rendered data. This is very important. So the initial request is always the cached one, unless there is an update. As I mentioned, after 30 minutes, in the background, Next.js will have, let's call a serverless function. It will call the API. Once the page has been successfully generated, again, static HTML, it will invalidate the cache and show the updated page to the users. This all happens in the background. There are no loading spinners, no nothing. So what happens if it fails? It will continue showing stale data, which means cached data. If this fails, that means there is an issue in our API. As I mentioned, we are now serving static HTML to the users. But so many people have asked me this question. They're like, but what if we need the fresh data from the API? For example, the results page has a section for an advanced search. People can go there and they can search for, in Pristina, I need all men at this age and what they voted. So how do we do this? We can't do this in the client side. We will have to preload millions of data. For that, it's okay if you do an API call, because you will have to think how many people will use that advanced search function. So we are just bringing down all the API calls to the server, which reduces all the costs of actually having, let's say, a very well-structured API system and backend and all of that. So with this, the results page now can be scaled indefinitely using CDN platforms like Cloudflare, Netlify, Vercel. Vercel is mostly used for Next.js. This is also very important. The API call is no more exposed to the users. As I mentioned, the Next.js will handle this in the background using a serverless function, so the users never see our real API endpoint. Users never wait for the data to load because it's already there, because we already prefetched it for them. We don't need to scale the API server most of the time. We reduced the server costs and we saved some cache for the client. So these are the issues that you can solve with this just small trick, I will say. You can also use Next.js to serve live data, but this is just one of their features. I didn't focus this presentation on Next.js only because that would have been very technical and specific. This is just a concept. It can be applied to any new meta framework. It's what they call them. So static HTML can scale. It's another presentation. And So we have another case study, which is how much do you think the client paid in server costs for this traffic? I forgot to add an animation here, but basically this whole website was hosted for free in Cloudflare Pages. So $0 were paid for this traffic, and it was a dynamic page. So the API was hosted somewhere else. We just fetched the data, showed it to the users as static HTML, that's all. And most of the time, you don't need to pay for static HTML. It's, on most of the services, it's free. If you were here earlier on Fisnik's presentation, he mentioned Azure static pages. That's also a service where you can use this kind of technology to basically get away for free with high traffic websites. So going further, as I mentioned earlier, you can also generate 100% HTML websites, meaning no JavaScript involved, with Astra, which is kind of the new kid on the block in these frameworks. You can make your application with React, but let's say you only need read-only data, which is a lot of marketing websites. You can also generate 100% HTML, which will be very fast. Another point is that you can also pre-render unique pages. So, for example, if you are running an e-commerce store or you have unique pages, they can all be cached until they're needed to be regenerated. And they will only be regenerated once a user visits. So they won't be refreshed in the background for nothing. As I mentioned, this method is very useful for high traffic websites. E-commerce websites use this a lot. And you can host this basically everywhere. The two concepts that I shared today are one for Next.js, which is their official website there. And the second one is this whole concept of serving static HTML with remote data, which is usually called Jamstack. And on their official website, you can read more about this concept, all the frameworks that support this, and how you can leverage this as a system for your next application or website. Questions? Yes.
Yeah, first of all, shame on you for the PHP statement.
It's an unpopular opinion.
Yeah, I'd like to raise a scenario because your case study here, I don't know if it was like enough in terms of the other case studies. For example, let's say we have Gatsby.js. I've seen and worked with that framework mostly for e-commerce clients, and it does wonders, absolutely, because you have static websites and stuff like that. What I was thinking was, what about mid to large-scale enterprise applications in which real-time data is more important than anything else, really? So I don't know if you had any experience in that regards. Like, what would we do in that case? I think the best approach in that case would be scaling horizontally, but I don't know. That's why I wanted to raise this scenario.
That's a great question, actually. Usually, those kind of applications, they have a very good backend, and like the API doesn't have any issues. It's not outdated. The system is well maintained. It can scale horizontally, as you mentioned, not vertically, which costs a lot of money. But also, as for fetching and client-side fetching, there is this rule that we have at work: is we almost never use Axios or fetch. So if it's client-side fetching, we use SWR. It's a hook from Next.js, but you can use it in every React application. There is also React Query. You've probably heard about it. So these are data fetching libraries, and they help tremendously because they cache on local storage every call. So they will, in the background, they will ping the server only the HTTP code. If it returns that there is a fresh data, it will only then clear the cache and serve new content to the user, which is what currently a lot of applications, as you mentioned, enterprise applications are using. And this kind of removes all of that front-end boilerplate of global states and stuff with Axios and Fetch, because you don't need it anymore. those kind of libraries handle that for you. So in those cases, we usually do that. So we always reach out to data fetching libraries that handle caching, reinvalidation, and live updates, which are, as you know, as a developer, 3 most important things. If you do them manually, it's very hard and a lot of mistakes can happen. So that's our solution to the question that you asked.
Okay, and also on that note, I see that you're talking a lot about Next.js. I just want to get your honest opinion, like what is it like to work with Next.js, rating it 1 out of 10 in terms of community support and stuff like that? How did that road go, you know?
So I have an unpopular opinion about Gatsby, which I didn't write here, is that I don't like being pressured to use GraphQL, which is what they use for frontend. I don't really like it. And for Next.js, actually, I like the whole concept and ideology of how they handle stuff, the file-based routing and everything. So for us and our use cases, applications that we've worked with, for us, it has always been 10 out of 10, either with experience, hosting it, or anything else. But there are certain scenarios where you might reach out to other frameworks. For example, as I mentioned, if you're only serving read-only data, I probably would have go with another meta framework like Astro, where I can write to React but generate static HTML for page performance. Because why would you give the client React like Next.js does if it's only read-only data? For example, a docs page or a public archive or something like Wikipedia or something else. So in those cases, personally, I will reach out for another framework. But if it's for data-intensive, real-time client fetching and all of that manipulations, always Next.js, at least in our opinion.
Also, just one more thing, sorry, because I'm... in regards to e-commerce websites, which are very keen to use these technologies, there's also an activity called A/B testing, and you have different groups of users seeing different kinds of websites and versions of the website and stuff like that. Does Next.js offer this kind of mechanism in which you can kind of split and funnel down the user experience in different cache static websites?
Yes, they have they did this now with version 12, so it has been around now for a year, I think. It's called Next.js middleware. With the middleware is a middleware, so it intercepts between the user and the server. So with middlewares, you can do A/B testing, get users' location, server-side React, which is going to be huge in the next years. So they have this now going on, which you can also do A/B testing. And actually, we just did that for a client recently. And it's very easy to set up because Next.js, for every concept that they explain, they have repos where you can see example code. And it's not just an example code, it's usually a working example code. So they're very efficient on that.
Thank you.
Thank you too for the questions. Any more questions? Thank you.